Okay, let's start. We continue the discussion for the fourth module, dimension reduction. In the previous class, we discussed the basic functions for data from the pandas database, the panda Python package. It can support several statistic calculation, average, median, and mean value, average value, standard deviation, and counts percentage. It can be applied directly on the data using the dot followed by the equation name and the parentheses. You can use the line to obtain the size. And you can also get the new matrix without a null value. And we can also get the correlation calculation using CORR function for the data. And we can define the decimal point number. Yeah, two numbers after the decimal point, round two, parentheses two. You can define more digits out of decimal point. So this is very useful when you investigate the original data. Yeah, you want to know what's the relationship between each other. This just show the linear relationship. It's just one variable linear relationship. Yeah, just one-to-one. If you find the relationship value correlation questions very low, that does not mean it has no contribution for the estimation. Actually, in the data mining, we will use the multiple linear regression model. It will investigate the multiple variables for the estimation. This will increase the accuracy from the multiple factors. So this is working out. And we also discussed the function CUT to divide data into multiple bins. Yeah, so cut data into different bins. So this will realize the categorical conversion from the numerical value, from the continuous value to the categorical value. This is a good way for the conversion. After you realize the conversion to the categorical variable, you can convert it to the dummy variables. We can use the function group by for the data. to realize the grouping of data using multiple variables. Now here it uses the two variables for the grouping, two key variables. After the grouping, we just use one variable value for the output. Yeah, we obtain that variable with mean value, average value. So it's better to read code so that you can learn how to use the package functions to take usage of the data source. Yeah. Previous one, we use group by the data. And next one function is the pivot table to create the data into pivot table using vertical dimension and horizontal dimension using two variables. And the value will be third dimension. So it's a pivot table. Yeah, to take usage of this pivot table, you should make sure the horizontal direction, the columns should be one clerical variable. Chess is one dummy variable here. Yeah, so it has a limited number of the columns for the calculation. And we also discussed the conversion for the clerical variable to dummy variables. Yeah, one m value clerical variable can be used to create m or m minus one dummy variables. Yeah, some situation this conversion can obtain m dummy variable. Sometime it will create m minus one, depending on the situation. This conversion will increase the variable numbers from 1 to m minus 1. So you will have too much many variables after this conversion. So we can consider combining several clerical variables into one. Okay, this slide for the combination of category variables using the stack bar. This figure shows horizontal direction with Z in the zone number. And the vertical direction will be percentage for the distribution of CAT MEDV. The CAT MEDV is one dummy variables. Yeah. So we can combine the CAT MEDV with the CHAS. So two dummy variables will be combined together. Yeah, from the percentage, we can know how many CHAS how many KLMDV show the CH value with 1, or how much many showing the CHS value with 0 for one same Z in value. Yeah, so we use one value, just put numerical value to represent two dummy variables, two category variables. Yeah, currently we don't use this one conversion because this will increase the complexity. Yeah. This is the code for stacked bar chart. And we call the function crosstab for the variable cat MEDV and ZIN, two variables using this crosstab. So we can realize the statistical calculation for these two variables. And when Z number is determined, we calculate how many cat MEDV value is 1 or 0. Then we realize these statistical results to TBL. Then we calculate the summary and or divide by the summary total value. So we can get a percentage of value to the prob TBL. And this run the numerical value to 2 digits of the decimal point. So we can realize this tables, percentage tables for different Zane number. Okay, then we call the transpose function. And this will inverse transpose the matrix. Vertical direction will become horizontal direction. Horizontal direction value will become vertical. Then we plot this 2D matrix. And define the plot is a bar plot. And it's one stack bar. And stack bar is enabled. Then we necessary to define the ticket label. And this will define the the coordinates, yeah, along the y-axis. Yeah, just mark the axis with different value. Here we use a format percentage, just 1.0%. This will just show integer without a decimal, without a digits of the decimal point. Yeah, so it's 0%, just no digit, no number of the decimal point. And this format is applied to everyone tickets, everyone a mark on the y-axis. Yeah, so the everyone value on the mark of y-axis will use this format with 0 digits of decimal point. Okay, next is the PLT title. This is to define the title of the plot. Yeah, title will be on the top, this title. Okay, just now, the set y-ticket label is this here, y-ticket number marker, and y-asset ticket, yeah, from 0% to 100%. So without the value of decimal point, just integer value followed by percentage. Okay, next to define legend. Legend will be the here. This legend, chess 0, 1. Just for the marker, okay, the color, the marker definition. You know, the blue color mark in the plot is 0. The yellow is 1, value 1. Chess value is 1. So the legend, ROC for the location of the legend is in the center left. Center left should be this center. Left should be here. I think this is the right, center right. So a little, I think it's a typo. We check the source code later. Next is the BB box to anchor. So they define the Langer location to the boundary. Yeah, from the left, center left is starting point here. Then in the horizontal direction, it shift 1, y direction shift 0.5. Okay. Nextly, to enable the display of this plot, when you define all above, it will not display. Yeah. If you didn't run the last one, this will enable the display for the plot in one figure. Yeah, so this should be run. So finally, the display format will be this. So this should be center right for that one figure. It should be center right. Okay, here we have questions. We can verify code and compare the features. Of the pivot table and a select bar.
Can you go back to the chart again, if you don't mind?
Okay, we go back.
What page 14?
Okay, give us a button.
Difference between the
So just sorry, I just speak louder.
okay. It's asking us what's the difference between the pivot table and the stack bar chart.
Yeah, step bar, pivot table, select bar.
Okay, that's on page 14, right?
Yeah.
Yeah, okay.
Should be 14, and also the pivot table. Yeah, pivot table here.
Okay.
Yeah, pivot table.
Let me see. Stack bar chart. Because the stat bar chart, it shows us the related values that are stacked on top of each other.
Mm.
Okay, and the pivot tables reshape the data. And when you have a pivot table, it kind of groups the data, so it's a lot easier for you to see how the different variables stack up against each other.
Mm. Yes, it's difficult to see the distribution for the variable.
Right.
It just show the calculation for one variable, the MEDV.
Median variable. Okay.
Yeah. This is just the value 17,
Mm-hmm.
and the other one 22 is not percentage. Yeah. This situation is a critical variable, room bin. It's already converted numerical value to a continuous value to the critical variable using the cut function. This critical variable, just like very similar to this one, Zn, this critical variable, this bin result from 0 to 100. The 100 bins, here's 100 bins.
Mm-hmm.
And yeah, the everyone Zn, the distribution CHAS, how many one, how many zero, according to, oh sorry, it's should be this CAD MEDV. Yeah, to calculate on the CAD MEDV. So I think this is the typo. It should be CAD MEDV. So this typo, I think it's typo. And we will check the source code. because there's no information for the CHAS from the source code. So we can check, it's better to demonstrate using the source code. So I launched the Anaconda. So let's see what's happening for the comparison between the pivot table and the stack bar. So all these tools can demonstrate multiple variables in one plot. Now, do you have any questions for the homework?
No, so with the homework, we essentially have to just run the models with the two data files that we were given, the West Roxbury and the Boston housing, and then answer the question that was given and provide the Python output, right?
Yeah.
Okay.
So you already resolved the problem?
I ran the problem. I haven't uploaded it, but I ran the problem, ran the files, the Jupyter file, and then address the questions because it's asking us to plot the regression summaries. And then there was a question that says, which ratio can provide a better model? And basically provide an answer for that question. So
Yes, actually
right.
the best one will realize the lowest error. The parameter can provide lower value, lower error will be the best one.
Right. Because there's a statistical model, regression statistics, that provides the output, for the plots that's provided. And in the output, it gives the mean error, the root mean square error, mean absolute error, mean percentage, and mean absolute percentage. So it's looking at those statistics, which for me, I looked at the mean error just to compare what those numbers were. And based on those numbers, which provides the better fit. That's
Yeah.
how I read the question.
Yeah, yes.
Okay.
Yeah, the low error is a better fit. Yeah.
Right.
Better fit will be more accurate.
Mm-hmm.
Yeah. Yeah, you're right. So we launch this.
Mm-hmm.
Module 4. Need to load the module 4. Go to the so you can download from the course website. In the module 4 dimension reduction. So you can download this ZIP file and extract it and upload to the Jupyter. So I already have on my computer. I will not download link. So actually, the extract results just like the ZIP. It has these files. There are code here. This Python notebook file. I will upload this one and also the three data. So I need to extract all this. So how can I do that? So you can open and extract. So you extract in this folder. So we can upload this. Okay, I will not upload Python file, py file. That's the notebook and the database. So go to the home. I just drag here, override. Because the database are the same. So I can override. So I open the notebook file. You can also run this code and data on the Colab. Yeah. If you don't have your own computer, you can use on-cam computer and do the similar way. So I can run it, run one by one. Just click run. So now it's running the import package. Yeah. Then so this is display the original data, 10 records from 0 to 9. It should be 9 records from 0 to 8. That's 9. Okay, describe to calculate the statistical value, count, mean, standard deviation, minimum, maximum, and a percentage. Yeah, 25%, 50%, 75%. So 50% is the medium value. 25% is 25% medium. 75% medium. Okay, next is to print results for the individual calculation. For one variable, this for the crime variable, we get calculate the every value, mean value, standard deviation for the variable crime, and the minimum maximum value for the crime. So the display data here. And the next, we build one data frame using this is just like one a dictionary. Okay, one field for the key, and the other one will be field will be value. Okay, so this different define one dictionary. The mean correspond to the value mean value for all the variables in the database. Okay, standard deviation will be all the variables. Above the print, just the calculation, one variable. Now here, you can apply this function to all the variables. Yeah, on one data. Yeah, on one data. This data contain multiple variables. So we can run and see show result here. Okay, next is to show the table of the correlation questions. We call the CORR parentheses. This show the linear relationship correlation between two variables. Yeah. 。 If you want to see the relationship between multiple variables, you can use the multiple linear regression model to obtain this regression model. And you can check the coefficients weight for different variables. So you can learn which one contribute much, which one contribute less. Okay, so we go to next. So this to obtain the value counts for variable CHAS variable. So let's see. So for CHAS, which is Dharma variable, the value 0 has 471 cases, and one value has 35 cases. We don't use the values, just count. Just return all the, so you can, yeah, so you can, that is different with count. We can add this. This is not display, you can print. Yeah, totally records is 506. And the next, the user value counts will be the number of cases for individual value. Yeah, so these two cases summary will be the same at the top. Okay, we'll continue next. Next is to use the cut function to convert one continuous variable to category variable. And the new variable is a ROM bin. It's a category variable. So we can calculate this. So you can see last one will become a category variable with integer value. This value is from 0 to 9. Yeah, totally 10 values. You can also define with 100, but this is not variable to this one case. The room is not a big value, just from 0, maybe the maximum maybe 15, but it form them to convert it to this small range of the bin. So you can get the, so you can calculate the, okay, we actually already have the calculation, don't have the calculation of calculation for the ROM. You can see ROM minimum is 3.56, maximum 878. Okay, so the biggest not high, but it is convert map to larger range, yeah, from 0 to 10. So this maximum is just 8.78. So map to a larger range. Yeah. So original this 6, 5, 7, 5 convert to 6. 6, 4 to 1 convert to 6. And 7.18 become 7. Yeah, 6.99 becomes 6. So it's not the round, just get the integer. Similar to just get the integer value. It's not a rounding. Yeah, but it realized the binary value. Okay, the category variable. Okay, then we continue this. Yeah, we finished this already. We click the count. Then we convert the continuous variable to empirical variable. Okay. Then we group group the variables. And group the table using two variables, Rongbin, CHS. They are both category variable. And chess is a binary, a dummy variable with two values. And the value will be the mean value for different group. So we can realize a group using two variables. You can also use one variable, three variable, four variables for the grouping. Yeah, this will create more groups using more variables. So you can also like us so this we can add one extra category variable to CIT MEDV. Yeah, because above so that MEC cat MEDV is also one category variable. So let's see what's these results. Yeah, but I show error. Oh, I input error. So MEDV. Okay, the results is like this. We have three three variables for the grouping. So you have more groups here. We can compare the difference. We can add one extra. Usually we don't have this. Now we run this one, and we also run this one. So we can have more groups. The top one, 11 groups. The bottom one is more than 11, maybe 20, 20 groups. Okay, next we run the loading the data from Boston Housing, and we rename the variable, the change name cat dot blank space MEDV to cat underline MEDV. So this remove the dot underline or dot and the blank space with one underline, and convert the variable LM continuous variable to category variable Rongbin. Okay. Then create a new data from the variable Rongbin and chess. We use these two to group the data and return the value of the MEDV. So these results show this. They just show the head, 5 cases. Actually, there are many cases because Robin has 0 to 10, and the chess is 0, 1. So it will be more than these 5. So we can just show all the values. We can print MRT to see what's the results. So it's more than it's 500, 506 cases. This just match the variables, 2 fields, Robin and CH. It's just a match. The join 2 variables, 2 fields. This does not make any calculation. That's we can continue work on this. Just we can make the mean value. Mean value just return 1 value. It's not a different groups. We calculate the mean value for different group. That will be the tabular table created by the group by. Yeah, we can use this group by to realize this calculation. But here is math is different. It can't make this calculation directly. So this just return total mean. Yeah, it's not an individual group. Yeah, conversion problem. So we can enable this and show the head. Yeah, the structure shown with yeah 4 columns. Robin has a variable name and values. So it is not a line matrix. So you can't because this variable is not one variable. Yeah. So it's one data frame. It's not because variable, this column can't be calculated with the mean value. You can only calculate on the value part. So it will be the value for me. Yes. Yeah, so you can calculate now. So this match results is not one table. It's not table. It's one data frame. It's not totally value. Okay. Do you have any questions? Yeah, this is not available in the lecture. So that's why it's seem different when we discuss in the lecture. Okay, next is the pivot table. Okay, it report one warning message. Warning message is fine. It does not care because usually the Python version increase year by year. So the old version code will be not support new version Python. So it's one version conflict. So it will provide the warning message. Warning message is fine. Only the errors we need to take care. So it's a pivot table. It uses the met data. Met data is above here. We use the value. This column, the last one column, the index use the ROM bin, and the column use the CHAS. So this is the RM bin is vertical duration, the first dimension, the vertical duration. The horizontal duration use the CHAS. So we can, and the value is from this one, last one column. So we can build one new table from the met matrix. The met matrix is from here. And we call the aggregation function for the value. It's the mean value for the value here. So they can realize the group by using two variables, ROM bin and CHAS. Okay, the value for one group, it has many values, many MEDV cases. And for these many MEDV cases, we can calculate the mean value and show this mean value for different group. So this will be similar to the group by the tabular table. And tabular table. Yeah, tabular table here. Yeah, similar like this. So we can use different group, and the third column is for the value for different group. It's very similar to this. So we can continue. So we can see the vertical duration is a ROM bin. Okay, in the 0 dimension, 1 dimension, the second dimension, horizontal duration is a CHAS with two values, 0 and 1. And for every case, we get the mean value for the the value is for MEDV calculated here. Okay, this is the method to create a pivot table. We have the other one method, just using original data. And the value is from MEDV. That's for the value. And the index, horizontal, the vertical direction is romping. The column in the horizontal direction such as it will be the same as before the top one. Only difference is the value and the data source. Yeah. Previous one data source from the MET table, graded table, using the MET function. Bottom one is original data. We use the value from MEDV. Top one use value from the credited value from the MET function. And the others the same. Yes, okay, can get these results. We can run this. So we can get the results the same as above, the same. Yeah. So you can realize the same results, pivot table using different ways. So the second method is more convenient. Yeah, just directly get the result. But the previous one, you need to two function call, MET and pivot table. Okay, next is a cross table. We call the cross tab function on the variable cat underline MEDV, and the other one variable is a Z in. So we can use two variables to create the cross table. Two variables. So then we divide the return results by the maximum. Okay, the summary, all the case, not all the cases, all the summary, all the summary together of all the cases. So we can get a percentage. Then shown like this. The horizontal direction is for the cat MEDV, the first one variable. Horizontal direction for the second variable, Z. So the value will be the decimal value from 0 to 1. Yeah, because this normalization function processed all the data. So this is just create one new table from original data using two variables. We can use these two variables, build this new table. So we can compare this percentage results with the original data without percentage before the division. Before division is a big number, 339. Yeah, while the conversion becomes 0.91. So the percentage will be divided by all the summary along the vertical direction. So this 339 plus 33 will be 372. We divide 339 by the summary of these two values, will be 0.91. At the bottom one will be the rest. Yeah. So be 33 divided by the summary of these two. So the next column will be the same. Will be summary of this column will be 10. So 10 divided by 10 will be 1. And 0 divided by 10 is 0. Yeah, you can do this for the other columns to obtain the percentage. So you can see from this code, the percentage actually the distribution of the ZN along CAD MEDV. Okay. Then we can plot the results like this. So this use the cross tab to obtain this table like this for two variables, CAD-MEDV and the ZN. And we can divide the summary value for every one column. So we can get a percentage along vertical direction. Percentage along the vertical direction. So this one, you can see the center left, the different center left, the both two anchors 0.5. So we can change this to see what's different. We don't use 0.5, we use 0.0 to see where is the legend here, where is the legend. We can rerun. So you can see the legend become left corner, left bottom corner. Now 0.0 is this 0. This is 0.0 will be the left corner. So this value will be the coordinate in this figure. Yeah, so the value will be percentage. The maximum will be 1. The 50% is the middle. Yeah, maximum will be 1. So the horizontal direction, the first one value is for the horizontal direction. We want to put here will be first dimension will be 0.50%, 0.5. Yeah. And we don't change the vertical direction, only change horizontal direction in the first dimension. So you can try 1, 0, to see what it is. And here, so the first one data is for the S-axis, horizontal direction. Second is 0, we did move. If you change it 0.5, will be move to the middle on the horizontal vertical direction. Let's see the legend location. We go to middle. Okay, it'll be the same. So the figure in the lecture is not correct. The legend name here not defined, but in the lecture is wrong. There's no relationship to the CHAS. So we need to remove this. Okay. Yeah. So this CHIS is not related to this stack bar. Okay, only two variables to determine the display of stack bar, the cat MEDV or and a ZIN. Okay, we'll continue this. So we can answer the questions for the comparison of the code for pivot table and a stack bar. The stack bar can support display two variables. Yeah. Here example is cat MEDV and ZIN. Yeah, for one variable is determined. Usually the ZIN will be the in this display similar to the bin character variable. It already been from 0 to 100. Okay, we continue. Yeah, I want to investigate the data uh, from the cross table. You can insert more cells to investigate the detail for the variables, KMDV and ZIN. Here ZIN show the value from 0 to 100. Yeah. So you can access the data from the Boston. Yeah, so ZIN. So you can return the types. series. So it's a float point type, the continuous variable. Yeah, mostly it's a 0 for the Z. So we'll continue. And for the case, just now we discussed status bar. This is created by two variables. At least the one should be the chemical variable. So we can see the distribution in one dimension. Yeah, use different percentage. So one variable should be chemical. And the other one, then, can be the continuous variable. Yeah. It's better than also the chemical variable, so you can see the clear diffusion. Now the other one, pivot table. Pivot table will need the two variables for the location of the groups, and the value is displayed with the third variable from these results. So this requires three variables for the pivot table. Yeah, so this difference, the pivot table will be the three variable. The status bar will be just the two variables. And show with different results. The status bar just show the percentage distribution for one chemical variable on one the other one variable. Yeah. So it show the percentage value for one variable. The pivot table will show one value of third variable. Okay, next we'll discuss the data reduction. And before just discuss the data display from the table, we can iterate different variables to show in a different format to show the relationship between each other. And now we will discuss the data reduction. This data reduction method is the principal component analysis. This can reduce the number of variables. Yeah, this try to remove the dependent variable, because the dependent variable closely relate to each other. Actually, they have similar information. So it's not necessary to store the redundancy information. So we just save the common feature and remove the small individual minutiae value. So we can realize the small number of the numerical variables, which contain most of the information. Yeah. So this also can be used for the data reduction. Yeah, we can use this PCA to reduce the variable number so that we can save the data, save data space. After the principal component analysis, we can create new variables of this conversion. Yeah, every one variable is one linear combination of original variables. So it's one mapping. Yeah, it's not one-to-one, it's many-to-one or many-to-many. Yeah, many-to-many, because output also many, input also many. Yeah, one variable contributes to other many variables. So this will be the weighted average for original variables. This linear combination uncorrelated because the correlation is one-to-one between two variables. So we can use only partial variables to contain most of the original information, the most original. Just a few to represent all the information. So we can call this new variable as the principal components. This idea actually from the representation of one space. Yeah, just like the three space is used SYZ. You can represent any one point in a space using three value SYZ. Yeah. And these three axes are vertical to each other. This idea actually will be the same as the principal component analysis. The first one variable will be the major base, major base. The second variable, the second chosen major variable will be vertical to the chosen variable. Yeah. So you can select the third one variable, and that will be also vertical to the previous two chosen variables. So this is the principles of the PCA analysis. Now here we apply new data, the breakfast cereals, and that contain the nutrients. For different brands of the cereals. 加了 100% brand. You have calorie, protein, rating. Yeah, manufacturer is N, type C. Not sure what that means, but we will interested in the others fields. Yeah, calorie 70, protein, and rating 68. The number is interesting. Yeah, previous brands type not much interesting. So we have this description for different variables. We can name just name brands, manufacturer type, cold or hot, is pepper spicy or not. Calories is an energy, protein. Yeah, for the ingredients, so the fat, sodium, etc. Potassium, vitamin, shape, available on the shelf or not, weight, with a unit ounce, cups value, and a rating, consumer reports rating. So we can calculate the correlation correlation matrix using the COR function. Okay, this is not correlation. This to obtain a variance. So we can go to the code that can easy to follow. So we load the serial data from the CSV file. Then we calculate the PCA. And we define the number of major components. This is two major components. We just obtain two bases from the original data. We use two variables to represent all the information. So we use this PCA model to fit the data, the serial DF. We track two variables, calories and rating. So we convert these two variables into two new major components. So you can see the results. So it's calculated already. Then we can show the results. So we build a data frame using several results, standard deviation, using the SQRT function, using the principal analysis results as planar covariance. Yeah, as planar variance. So it's a square root to obtain the standard deviation. Then the proportion of the variance, this is from the S-plane variance ratio. And third is the community proportion. And this is the sum on the PCS S-plane variance ratio. Then we call the transpose function on the summary data frame. So this is actually in the this actual field will be the column name. And after this transpose, this column name become vertical direction. And we redefine the column name with PC1, PC2. And we define a number values of the decimal point with 4 digits. Okay, next to display the principal components. We assess the principal components training results and obtain the components and make a transpose. The switch the horizontal and vertical direction. And define a column is PC1, PC2, and vertical direction, calorie and rating. So display results will be here. So Because we obtained the data originally from calorie and rating, now we just define the converted results, the mapping to the calorie and rating. The PC1 components, the first one variable, the contribution from calorie is about 84.7%. The rest, the other variable rating has a weighting negative 0.53. For the second converted principal component, it has contribution from calorie with weight 0.53. And the other one weight 0.84 for the rating. So this just shows the conversion results display using the table. Okay, then we run this one. This will use the training result for the principal analysis. Now, this transform the original data, serial DF. We use the two columns, original data, calories and rating. Then we make a transform on all the data, on all the two columns, using the two components, two principal components. Yeah, and define the converted results, the column name, the PC1 and the PC2. So you can see the results here. The converted results will become the flow point value. And this is just the top 5 records. Yeah. You can print all of them for all the cases. So you can print. So actually it's many records. Yeah. Many records. So it's 77 records. Yeah. Yeah, every records have 2 values on 2 bases, 2 principal components. The first components have weight negative 44.92. The second principal component has weight 2.919. Okay. Okay, the top table is a conversion training, the training results. This 2 principal components can be derived from the training data of the calories and rating. Okay, this is the creation of the PC1, PC2. The next one, we use the above results, PC1, PC2, on the original data, so we can realize these conversion results. So you can see the difference between. Yeah, they are different. So you can compare the difference between before the conversion and after conversion. So the before will be these 2 values. You can compare the difference. We add 1 value, so we can print. So the original value, then we display converted value. Let's see what's the difference. So this is the okay. So we can see before conversion, the first record 70 and 68. After conversion become flow point, become negative 44 and 2.19. So you can see the feature of this conversion. The PC1 has a major information. This has a higher weight value, negative 44, but the second component has very small value, 2.19. And you can see the second record 15.7, but PC2 very small, 0.38. Yeah, so you can see others will be similar. But this 73 is a little different, but almost the same. But you actually, PC1 will be the major information. PC2 will be weak information. Yeah, this was this functionality from the PCA. Yeah, so PC1 will be a major, first major. Second will be second major. Yeah. So we continue next one. This will be similar to above. This also called the PCA model. Then train this PCA model using data from original database. It used the columns from third column to the rest. Three column from third column. 0, 1, 2. This will be from 2. 0, 1, 2. From 2 to the last one. Yeah. Then use this. So this will remove the previous two fields, two variables. Because previous two are operator type are string. Yeah. The first one is name 0, 1, 2. Oh, okay. From 3 or index 3 from calories. 0, 1, 2 are omitted for the conversion. Only work on the calories, protein, and the last one rating. Okay, from the index 3. Yeah, index 3. Then we train this model using this data. Then we build the data frame about a table, build new table. Okay, the horizontal direction is the standard deviation, the variance, and proportion. The SQRT on the variance. And the second is the variance ratio. And the cumulative variance ratio. So cumulative proportion will be the the addition. Yeah, the first one variance just its own self. The second, this cumulative value will be the summary of previous two. The third will be summary of previous three. Yeah, so it's a cumulative summary on ratio. So the last one will be 100. Yeah, because it's a cumulative, all the value in that column will be 100%. Yeah, previous one will be individual percentage and proportional variance. The first one will be the variance individual value for different principal components. So we can get the results. Okay, and we get this that frame. Then we make transpose, the switch, the duration, the standard deviation. Originally here is the horizontal line will become vertical duration. And different components will be switched to horizontal duration. And we rename, we use this column. We define columns of duration variable name with PC. But this curly braces, this to define one variable. And this to use variable, we can use variable inside the curly braces. Now here we use the format I, yeah, the I in the range. Yeah, the number of the integer numbers determined by the variable numbers, column numbers. And so it starts from 1 to the last one principal components. Okay, then we define the decimal point number, 4 digits of decimal point. Okay, so result would be like this. So you can see PCI standard deviation is the largest, the 83.7. PC2 is 70. And PC3 is 22. You can see from the left to the right, the standard deviation becomes smaller. And finally, the last one, almost 0. Yeah. PC12, very small, 0.063. And you can see the second row is the proportion of the variance, will be percentage. That use this individual standard deviation divided by the summary. So this is 53.95%. The second 38%. Third is 3.9%. So you can see the weighting decrease from left to right. And you can make the cumulative summary. Yeah, just summary for this one, just its own self the same. Second of this number will be summary of these two. Yeah, third number will be summary of the previous 3. The fourth number in the third row will be summary of the previous 4. Yeah, so finally you can see the summary of the standard deviation will be 100%. Yeah. You any question to this? These two help you to understand the PCI conversion. You can use this to convert the smaller size of data using small variable to represent all the variables. Is this very useful when you have huge data? Yeah, you can apply the PCI first to all the data, so you can realize the smaller size of the principal component analysis. You can use this to convert original data, and then use the small size data for the training and identification. Okay, we continue next one. Next, we build the data frame for the components transpose. So it'll be similar like this, the transpose. And we define the columns with the with the PCS summary DF, the above column. Column will be like this. Yeah, similar is the same as you here directly. And here we define the index. It's the index from the original data columns from third columns to last one column. Yeah, so it'll be calorie, protein, fat until rating. And the principal component from 1 to 5. Okay, this display just from 0. It's actually this DF PCM component DF has 13 columns. Vertical directions will be this. And now we just show the 5 columns from 1 to 5. So this actually show the conversion to create a PC1. PC1 has a weighting on different input variables. Okay, PC2 has weighting on different variables. So you can see the major contribution to PC1 is from sodium, so 98%. Yeah, the other, the second important from the potassium, 13.5%. So sodium is a major components to determine the major information. Now PC2, you can see where from PC2. PC2 is from the potassium, it's 98%. Okay. PC3 is from which one? Actually from this one, 62.9% from calorie. And the PC4 is from, it's a little debate, 60% from calorie and 33% from rating. And PC5, 45% from calorie and 30% from sugars. So you can see the conversion can realize storage of the major information. It's not simply one-to-one mapping. Actually, it's one many-to-many mapping. So we continue on the next one. This also use this principal component model to fit the scaled results of the original data. So this original data will be the same above, just use the third column to the last one. So you use calorie and until the last rating. Then before the training, we make the scaling. Before, the reason we use this scaling is that the value of the original data has different range. Yeah. Some variable has small range, some have very big range. So we can check the original data. You can understand why we use this. So we can see original data. So this is training. Before training, we can show the data. We can print. Hey, we show the time. So you can see for the protein, the value range is just the individual integer number for 3 calorie, the bigger range, 70, 120. Yeah, the big range. And also sodium also big range, but the fat is small range, 0, 1 to 5, a very small value. So when you use this for the training of data, it will lead to a big variance, a big deviation. It causes big error when you train the data. So it cause difficulty for the convergence. If we want to make more accurate results, you are recommended to make scaling before the training. So that's why we need to call the scale. Yeah, we call the scale on the original data. And before the scaling, we need to drop the NAR, the empty records. If there's any empty value, we just remove that records, then apply the scaling, then apply the training for the principal component analysis. Okay. Then we use this result to build a data frame standard deviation, the rate of the variance, community variance, then display results just the same as before. So you can see the difference. So you can see the principal component value becomes small. PC1 1.9192. Second, PC2 has variance very small, 1.78. And the percentage PC1 just 27.95. The second 24. Third one is 14%. Before you use this scaling, you can have the difference performance. The PC1 has about 53%. The PC2 38%. Now very small contribution. Equalized the contribution for different principal components. Yeah, so sorry, we miss here. We calculate this one already. Then next one, we display these training results, show the coefficients for different components. Okay, so we can see a contribution from different variables for different components like this. The PC1 is from the multiple variables, not measured from the sodium. Now, 30% from protein, the other one 30% from the calorie, and and 45 from the fiber, and 40% from the potassium. So you can see the contribution from multiple variables. So you can realize more accuracy estimation, because not only just from one variable. And next is for the plot. So firstly, we clean the empty records from the original data. Then we reset index. Then we make the scaling for the data from the third column to the last one column. And then make a fit training, PCI training of this model. And using this training results, we build a data frame and define the columns with the PC components, PC1, PC last line, PC 14. And next one we call the function concat. Concat is to combine two matrices into one. Okay, first one matrix from the the original data, serial read DF, that's already reset the index. We just use one column name. Another one is from the PC1 and the PC2 from the transmitted results, PCI component analysis. So it will be the the first one column is the name from the different records. And the second row, second column and the third column from the principal components, 1 and 2. Then we plot the data using the PC1 and the PC2 for different records. Yeah, the different records with a different name. So we can show these three, actually 3D data. And for everyone, so in this for loop, so it used SYS, 3 coordinates, 3D data. Every value is from the points, PC1, PC2, and the name. We get 3 value, and we get the test SYS. So as the first one, the dimension is for S location, Y location, Y duration, vertical duration. S is the horizontal duration, PC1. Y is PC2, vertical duration. And the third S will be the name, on the dot for that location. So the results are shown like this. So it's a mapping from original data to the PCI space. PCI space. The mapping results for different products. You can also show the make a plot using the original 2 columns, like the, but this is not directly map. This PC1 has multiple component contribution, just like the PC1 in above. PC1 from multiple variables, below also PC2. So it's not 1-to-1, it's can't make a directly comparison. Yeah, it's one representation of the original data. Okay, next is the code. Sorry, this is one arrow. Right, okay. No, just text. No module call, but just text. Oh, install with a just test to try whether server or not. So we can make an individual. Before this, run this. Okay, good. Then try run this focus skill or points not installed. Okay, now it's successful. Okay, now it's display the points PC1 and PC2. The previous one does not have the name. The bottom has the name. Actually, they are same. Okay, then we continue the last one. And yeah, it also show the name. Yeah, it will be the same. So it's not necessary for you to use this because this just show what's the results for the conversion. Actually, we will not use for the analysis. Just demonstrate the feature for the PCA. Okay, we next one use the data wine and make a conversion. This will be the same as before, so we can realize the conversion with 13 PC components, principal components. Okay, and this does not have the scaling. You can see the big deviation. It does not have scaling. Okay? You can see the fit. Yeah, fit does not make a scaling. So it has a big error, big deviation. Then we continue. Display the principal standard deviation, the big 300, and 99% is from to the PC1. PC2 just is very small. So major component is convert to the PC1. Major information from PC1. The other very small contribution, almost zero. And we can use this conversion matrix. We can display these coefficients for conversion. You can see PC1. You can see, yeah, measure from per line, 99.9, almost 100% from per line. PC2 is from the magnesium, 99. PC3 from the H, alkalinity. Okay, PC4 is measured from the color intensity, and PC5, 60% from malic acid. You can just show the conversion results. Now, do you have any questions for the code?
Once we get finished with this, I had a quick question, Dr. Wang, on the homework after we get finished with your lesson here.
You mean the quiz questions?
No, I'm referring to the homework question 2.
Homework question 2. You mean the quiz?
No, this is the homework, the data mining process and linear regression model lab, lecture 3.
Okay, I'll go back to that.
I mean, I didn't know if anybody had any other questions on the work that you did today, though.
Okay, let's see. Okay, 17. Oh yeah, due today.
Mhm.
This lab. We'll go to open this. Yes.
So I had a question on problem 2. So essentially, we would use the same Python script for problem 2 and problem 1. We just changed the file, the data file. So we just change it to Boston Housing and then change the variable
Yes.
total value to MedV. Is that right?
Yeah, yeah. You can see the code almost the same. Only difference will be the data source and the variables. The other are the same.
Okay, that's what I thought. I changed it, but I want to make sure that when I changed,
Yeah,
because
you are
what I
right.
did, I changed total value from 1 and I changed total value to MedV. So I want to make sure that was
Yeah,
right.
so
Oh, and change the
actually,
file. Okay.
these two variables similar to the top two. You remove the two and choose one for the output. They are very similar.
Oh, cat.medv and medv is what you're saying. Okay.
Cat MEDV will be omitted because they are dependent to each other. Right.
Wait, I'm sorry.
Oh,
You said
sorry.
I'm sorry. Let me make sure I heard you correctly. You said cat.medv would be omitted, or I'm using
Yeah, you
cat.medv
and
and
all
medv.
the variables except these two for the predators.
Okay.
These two removed for predators.
All right.
And only use this one MEDV for the output. So this one cat MEDV is not used for the prediction.
Okay. Got it.
Yeah.
Okay. Thank you.
Yeah, welcome. Any other questions?
No, not right now.
Yeah, I received email from student. He can't follow. Yeah, I answer email to him. He can attend class, ask question, but he not here. So yeah, if you have questions, let me know so I can help you.
Well, no, I had issues with like using Jupyter
Okay.
because of my screen jumping, but um you had let me know I could use Collab, so that was my only issue. But I'm still using Jupyter for now because that's what I have downloaded, and I'm using it for another class. So I'm trying to stick with that program.
Yeah, you can use either way. You can use the Colab. You can also use the Jupyter. The Jupyter may be more convenient because you can load data directly from your computer.
Yeah, I like it. I like it better. I just don't know why it make my screen jump like that, but I do like it better.
Yeah. Okay. Yeah. Do you have questions for the usage? Yeah. If you have difficulty, let me know.
I
Okay.
did have a question. Will we
Okay.
be able to start having since you're going over the assignments like the day of class, would we be able to push back the date so that if we had issues afterwards, we would have a little more time to get the issues
Yeah,
resolved rather than,
you can submit later when you are ready. But you
okay,
should submit everything before the last day of this semester.
okay, thank you.
So I can review your assignments, give you score. Yeah. This course is not mandatory for the attendance. So we consider your specific situation for your work, for your family. Yeah. But you need to make sure every assignment should be submitted before the end of the semester. Yeah, any questions? Yeah, we try to finish the rest part. Okay, we already, we fit the data, make a transport, then display data using the new format for everyone components with deviation and community for the deviation. So we can see the contribution from input variable to everyone component. So we have question, what statement can provide a principal component analysis? Do you know which one function? Yeah. Anyone know that? So the PCA function and the PCA. So we can go back PCA. It will be this PCA parenthesis will provide the model principal component analysis. Then apply fit, they call the fit function for that model to train the original data to obtain principal component. Yeah, so you have two, one PCA function, the other one will be the fit function to obtain the equations for the model. And what kind of variance does the principal component Z1 have? Z1 component has the largest variance. Yeah, it has largest variance. The variance will be the information for the data. Yeah, if the variance is 0, that means the energy, the information are nothing. Yeah, then so just like the yeah, the larger variance will contain the major information from the data. So that's why Z1 is a major component with most information. Okay, before the training of data, we apply the normalization so we can reduce the deviation, because the previous without scaling, the Z1 has bigger variance. And out of this normalization, we can make a more accurate estimation. Okay, the normalization will be the same before. It divided by standard deviation. And before division, it need to subtract the mean value. Okay, this is the same display results. It will be a small distribution for the variance of the 28%. Yeah, we already discussed this in the code. And what can be done on each variable to remove scale effect? And this will be scaling, yeah, normalization. Use scale function for normalization to remove the scale effect. Yeah. The PCA in the classification and prediction is used to reduce the data size, reduce the number of the variables. Yeah, so we can apply the PCA model to the training data, so we can obtain correlations. And we can choose the major components. It's not all the components, just the major components. We reduce the size of the data. Then we use these created weights for different principal components on the original data, the training data. So we can get the converted result and apply also use this model on the validation data and the new data. So we can get the conversion results. So we can create a new reduce the size of data for the predictors. We can combine this principal component analysis with the multiple linear regression and the lattice regression. Yeah, because after this conversion of the principal component analysis, then we reduce the state size, then use the linear regression model or the regression model to realize the accurate prediction and the classification. So this will increase the training velocity and use small data and major information to realize the faster results. If we use the original data, you have to wait a very long time for the training. And now you can realize fast training. So Jala is the current very popular large language model like ChatGPT and DeepSeek. They especially DeepSeek, they use a small size data, and they reduce the size of data to realize the fast training. And they distill the others model, yeah, to obtain a small but more accurate data for the training to realize the best results. Okay, the summary for this lecture is to introduce the principal component analysis for the data reduction. And also we introduce the data summary using the statistical functions. And also we show how to display the data using several variables. One is the pivot table, the other one is the tabular using group by function, and also the stack bar display two variables using percentage. Okay, that's this. Is there any questions? Yeah, if you don't have questions, we just stop here today. I will upload the video link to the Blackboard later.
Okay, thank you.
You're welcome. Have question, let me know. You can send me email.
Okay,
Thank you. Good night,
thank you.
everyone.
Good night.
Bye-bye. Have a nice day.
Bye-bye.